So hi everyone, my name is John Sarafo, and for this video I will be showing you how to work with XFoil, how to test different airfoils and see the results of it. So let me first open up the program. You see, this is how airfoil will, XFoil will look like. So the first step that we want to do in XFoil is actually type the word NACA, hit enter. And then here it's asking us for the 4 or 5 digit airfoil designation. So you want to type in the number of the airfoil that you want to be using with. For this project, we're going to be doing NACA 2415. You see, so now we're working with 2415 and we have a number of nodes of 160. So we're going to hit pane, which smooths out the airfoil, and PPAR, the command, is to actually see the airfoil. I'm not sure if you guys can see that, but let me see real quick. Here it is. So this is your airfoil of NACA 2415 with 160 nodes. You can change the nodes. For the project, we changed it to 250 with a thickness of 1. You can change it to whatever you want to change it to. I suggest bumping up the panel nodes because for certain airfoils, we actually need more nodes or maybe more iterations in order for the results to converge. But I believe for this airfoil, we changed it to 250 and iterations of 100. So let me just do that real quick. Okay, we're back in airfoil. Let me change the nodes to 250, the thickness to 1, and then PPAR, and then there we go. It should be like that. Now we want to go, in order to change the iterations, we want to command OPER, and now iter. See, and now we just put 100, and now we're working with 100 iterations. Okay, as you can see here, it says OPER I. It means that it's working with an inviscid flow. For the first part of the project, we actually did all of it in with viscous flow, and for the sake of this video, I'm also gonna use viscous flow. If you want to change it to inviscid, you just type inviscid and you can work with inviscid flow. Now it's asking you for the Reynolds number. We're gonna use 1 million, so 1 million Reynolds number, turbulent flow. Okay, so once we have the Reynolds number, we want to actually change the results to polar. I wanted my plots to be plotted in point sequence. Exact. So let me show you my new airfoil now. You see, here it is with a 250 nodes and with a thickness of 1. Sure, let me go back to XFoil. Okay. All right, so once you're back in airfoil, you see you can change the alpha, the angle of attack. Let me click alpha 5. I believe the results should be in here. Or no, okay. All right. Okay. All right, in order to actually get the results, if you want to do it with an increment of 1 from -5 to 15 angle of attack, we want to use the command ASEC. Now it's asking us for the first alpha value. Let's do it from -5 to 2 to 15 with an increment of 1. See, now it's calculating with 100 iterations. And for this one, there shouldn't be any issues to converge. You see, everything has converged. And now the results, you can see them straight up in XFoil, but for this project we used the results and then we transferred it to Excel actually to plot it. Okay, so if we want to do that, we want to save what we have written. So we want to hit the command POC, start saving. The new file number, we're gonna use the file name. You can put it whatever you want. Let's do NACA 2415. And now let's do again ASEC -5 to 15 with an increment of 1. Waiting for it to calculate 100 iterations. And now it should be saved right into your folder of XFoil. So once you open the file into Excel, you can open it here, and then you can start plotting your results. You can see, as you can see here, we have the coefficient of lift, we have the coefficient of drag, and for this project we used the CL over CD, and for this one, XFoil does not provide it, but you could just create it by just hitting the equal sign CL over CD, and then and Excel is so much easier to just write it all down. So that's pretty easy. So yeah, so in here we have the -5 to 15. This is for the Reynolds number of 1 million, right? Yeah, this is for the NACA 2415. And these are other NACAs that I've also worked for the project. NACA 0011, 15, and the last one. So in here, in Excel, then you can just start plotting your coefficient of drag, your coefficient of lift. You can see what's the max, then the mins for the both drags and mins. For the drags and the lifts. You can also see your correspondent alpha values towards the CL and CD. You can see a lot of useful stuff. You see, as you can see in here, I just noticed that, but where is it? Oh, it's not here. Anyways, once we're in Excel, this pretty much has nothing to do with XFoil, but once you get your results to Excel, the rest of the project should be pretty straightforward. All right, and so I believe that's it for this project, what I had to share. So thank you everyone for watching this video, and I'll see you guys in the next one.